Hello, hello. Welcome to the SNIA webcast on Scale-Out File System Architecture Overview. Good morning, good afternoon, and good evening wherever you are. This is John Kim, your host for today's webcast. We will go ahead and get started and tell you all about scale-out file systems, how they're architected, and well, actually, let me go ahead and get to the agenda slide and the logistics slides, and let's get going. So first of all, today's presenters are Ziki Tao. He's an HPC or High Performance Computing Solution Architect. And I'm John Kim, Chair of the SNIA Networking Storage Forum, or NSF. And Ziki, can you introduce yourself and say hello?
Yeah, definitely. Hi, my name is Ziki Tao. My day job is HPC Solution Architect at Intel. And so throughout my jobs, I work with customer, partner, design, implement HPC solutions, right? And a lot of times that involve with the scale-out, storage, right? And so that's how I build up my experience. So yeah, today I'm going to talk about my understanding, and I'm open, to any feedback, comments from, community, right? And like we have this question and comments channel.
Yes.
Right?
Yes, we'll go ahead and the audience that's a good point. All of you listening are welcome and encouraged to ask questions online at any time. We'll answer as many questions as we can live. If there are any questions we don't get to, we usually answer those in an FAQ or frequently asked question list that is published as a blog, usually 1 or 2 weeks after the webcast. So a couple of brief notes about SNIA. So SNIA-At-A-Glance, Storage Networking Industry Association, or SNIA. We're composed of 185 industry-leading organizations. We have more than 2,000 active contributing members and more than 50,000 we work with or interact with more than 50,000 IT end users and storage professionals worldwide. A couple of just some legal paperwork or legal just notice to get out of the way here. This material is copyrighted by SNIA unless otherwise noted. Any member company of SNIA and individual members may use this material in presentations and literature with the following conditions: that any and all slides must be reproduced in their entirety without modification, and SNIA must be acknowledged as the source of that material if you use it. This presentation is a project of SNIA, and neither the author nor presenters are attorneys, and nothing in this presentation is intended to be or should be construed as legal advice, etc. This presentation represents our personal opinions and SNIA does not assume liability or responsibility for any damages from use of this information, so use at your own risk. Okay.
Yeah, that's a very good point. Indeed. I also want to add, this is my personal understanding, and I'm here to share my knowledge, not representing my employer. Yeah.
Excellent. Okay, that's good to know, Ziki. So this is you representing your personal opinions and not your employer's. So the target audience. This talk is intended to provide a general overview of scale-out file system architecture. It's not intended to show any preference for any specific or certain technologies. And this will also provide some general guidelines for evaluating scale-out file system storage designs and performance. Our agenda today is first, general principles when architecting a solution based on a scale-out file system, use cases for scale-out file systems, hardware and software design considerations for different workloads or different needs, some of the challenges and trade-offs that you may encounter when deploying scale-out file systems, then some common benchmark and performance analysis approaches, and then a brief overview of some of the popular scale-out file system options in the market. So I'll do a couple of brief definitions, and then we'll start with Ziki. So first, what is a file system? So a file system is a data management system that allows computers and applications, or people, to share, read, and write access to data organized as files in directories or folders. When I say organized as files, that means as opposed to not blocks and not objects. So, and not a memory, not a memory byte address that would load store command. So organized as files, then you're typically able to open the file and either get the whole file or open a range of the file and access part of the file. And there is the option for shared access with different users or different computers if security allows it. Now, what is scale out? Scale out is typically a solution that runs simultaneously on multiple hardware systems or nodes, and it utilizes the compute power, storage, and network capabilities of multiple hardware systems simultaneously. And Ziki is going to, at this point, we're going to go over to Ziki, and he's going to talk a little bit more about scale up versus scale out and what's involved in scale out file systems. Ziki, why don't you go ahead?
Yeah, okay, thank you. So as you can see from this diagrams, right, on the left-hand side, that's a typical scale-up system. Once scale-up really means we can increase capacity. However, and as we increase the number of hard drive or like a storage tray in the backend, and the access to the file system will still through the single or dual controller or server, right? And even have a two controller, we really just use that for failover or availability purpose, right? And so you can see the limitation is if we have lots of a client access this storage, that's a single server can still be the bottleneck, right? So that's the traditional scale-up solution.
So in scale-up, there's just one controller or one pair of controllers, right?
Yeah, exactly. Even have one pair controller, the two controller does not share the workload, only handle the failover, the function as active passive mode, right?
Okay. What about scale-out?
With scale-out, like we will have many controller, storage server, and they work together and form one namespace, right? Single namespace. And so from client perspective, they would not have to worry about which controller or server they talk to. They just connect to that particular shared file system and get data from there, right? So because we have a multiple server node to handle I/O, and so we will be able to have a more balanced performance. And this is particularly important when we have a lots of compute node on the other side, to actively read or write data, right? And so, but there also come this kind of scale-out architecture also comes with actual complexity. As you can see here, even with just a couple of servers, we already need to consider what happens if one server goes down. Like how I make sure would the file system continue function, right? How do I make sure like I have a evenly distributed performance, right? And in this case, if we have multiple server, if they are not taking I/O evenly, and we will still not get the quadruple times the performance, right? So that's the way. Go ahead.
So for scale out, you're saying we have multiple servers, they all have storage, and it looks like one namespace or one file system.
Yeah.
And you're saying we get extra performance, but now we've also introduced more complexity.
Exactly. That's the key point I want to discuss for the rest of our presentation, to consider if we as the customer or like an investigator to see whether scale-out architecture might suit my particular needs or not, what's the area I need to pay attention, right? And so that's we'll talk more in the next couple of slides. Yeah.
Okay, please go on.
Okay. So even with scale-out, there are at a large, like there are two general approach, right? And one is using dedicated storage server, and we have a dedicated client, right? It's really a storage client approach. They connect through most likely a high-speed data network, right? And as you can see from left-hand side, another type of the scale-out storage would be like a hybrid approach, right? So the on each node we will have a compute process, but we also have a storage server process, right? So then that's for those kind of architecture. Typically, they don't have a very fast speed like network between the node. So that's why you might heard about this kind of thing, like moving computation is more moving data is more expensive than moving computation, right? Because like if I have a data locally, I can instead of to ask another node to get the data to process, maybe I should be the one to process. Right? So that's the hybrid approach. So
okay,
there
so
are
in the dedicated approach, each node either does compute and runs the application, or it does storage, and you don't really mix them, right? So in the model on the left, every node is either storage or a client.
Exactly. Like on the right-hand side, each node will be both client and the server, right? So
okay, yes.
Yeah. Okay.
Okay, yeah. So on the hybrid model, and I think in, maybe not in scale-out storage, but in other worlds, the hybrid model, some people might call that hyperconverged, or it looks like hyperconverged, but each node is both the client and the storage. And you're saying that in the model on the left, with dedicated storage and client nodes, you usually need more networking bandwidth, or maybe faster networking. In the model on the right, because the data is many times close to the compute, you don't need as much networking or need as much networking bandwidth. Is that right?
That's right. That's right. And but there are pros and cons for each kind of approach, right? And for example, one general use case for the dedicated mode, right, and will be then we will have how to say the denser solutions, right? So because we have a special designed storage, and also we have a special designed the compute on each rack, we will be able to have a more computing power. On the other rack, we'll have a more like capacity, higher performance on the storage. But when we use hybrid mode, then because we need to consider both, and it's in the end we will have relatively less dense solutions. And typically for those kind of solutions, we use like a 2U server with a couple of drive in the front, right? And but the result is like it's not that dense anymore. And so for the smaller scale type of a solution and like environment, that the hybrid mode would work better. And but with as we increase to a certain level, let's say petabyte, right? And then you will find the dedicated mode work better, right? So.
Got it. So for a smaller environment, the hybrid solution might be easier to set up or easier to manage. For a larger environment, say, and you're saying maybe that's more than a petabyte of storage, then the solution where you have dedicated clients and dedicated storage nodes could be more scalable, and you said it's higher density, right?
Exactly, higher density. Yeah.
Okay. All right. Sounds good. Let's go on.
Okay. So here are a couple of common use cases, right? And the top one will be high-performance computing, right? And that's where, like, if you look at why we have a high-performance computing in the first place, and because we want to solve a complicated problem as quickly as possible, right? So most of the times, this problem comes with certain data set, right? So if we cannot get data fast enough, or like save results fast enough, we cannot move on to next job. And so therefore, like HPC is typically one special use case, and you will see like there are many different solutions for that. And also like for other in enterprise environment and wherever they have a large amount of data in the process, right? And especially we talk about each file a few hundred gigabytes, right? And how do we store that file? Right? If we put the file on one server, making it only acceptable from one server, and even just get this, a few hundred gigabytes or terabyte file, and can take a lot of time, right? How do we get a more scalable performance, right? That's also one specific use case. And in media entertainment environment, and one thing we need to consider is, well, we will have hot data and cold data, right? If the movie, there's a movie like very popular, you might find that data gets hit more than others, right? So how do we handle this kind of tiering, right, between hot data versus cold data? That's also involved with the scale solution. And the big data analytics is certainly another area, right, in getting more and more use of this scale architecture. Especially we talk about Hadoop Spark solution, you have the default storage HDFS. That's a more hybrid approach, right? So.
Okay, so you pointed out that for some of these applications here, you may have data sets that are so big that it's really hard, you can't fit it on one server, or you want multiple nodes, multiple clients, or multiple compute nodes need to access the data simultaneously, so a scale-out solution can provide better access or better performance, or better access, faster access to that data for multiple nodes.
Yeah.
And then you also pointed out that scale-out storage offers you tiering options. So you could end up putting the hot data on the faster storage and then the colder data on the slower, cheaper storage, right?
Exactly. Yeah. Yeah. That's also.
Okay, and then you also,
go ahead.
And then an interesting observation that big data, many of the big data architectures like Hadoop and Spark, or maybe even some NoSQL databases like Cassandra or other, I think by default they sort of use a scale-out architecture. As you were saying, it's similar to the hybrid solution where their default, maybe not the only storage option, but the default storage option for many of these big data solutions is every node is both a client and storage, and then so the storage is distributed across many nodes.
Exactly. Yeah.
Hey, just the logistics. We have a question. Would it be possible to get a copy of the slides? Yes, we always post the slides for these webcasts on the SNIA website afterward. Plus, the webcast will be available. You'll be able to replay the webcast in BrightTalk probably immediately after the webcast is over. Within like 3 or 4 minutes of the webcast finishing, you should be able to replay it. And then the slides should be posted within a few days. Okay, Ziki, please go on.
Okay. So let's talk about the design consideration, right? And so when we evaluate like scale-out type of storage, the first thing is capacity, right? Because that's how much capacity I need, the size and the growth forecast. And let's say I might need to double the amount of data I need to store next year, right? And so because of this kind of growth forecast, we need to design the expansion strategy. If I need to double my capacity, and what's the impact to my existing storage? Do I need to buy a new one, or could I expand the system without schedule any maintenance window, or I need to take a file system down and to come? So that's a very important aspect to consider, right? And the second model is like access model, right? How do I access this system, right? And typically for the large environment, we will use a certain storage network, right? And then we need to talk about what kind of protocol we're going to use and what kind of network hardware I need to procure, or prepare, and in order to to make use of this scale-out storage, right? And what kind of client software, right? And is the client software purely user space, or client software is require kernel patch, right? Because that would apply to different complexity to support this kind of this solution. Yeah.
Okay, so with capacity, you're saying that you have to understand what your growth forecast is and have a strategy to expand the storage to meet your capacity needs. And on the access side, you need to think about how are the clients going to access the storage. What protocol or protocols they're going to use, what kind of network will they use, and will you need a proprietary client installed, or will you be able to just use a standard protocol like NFS or SMB? So there are different ways, because there are different ways to access the storage with different scale-out systems.
Yeah, exactly, right? Some of our solution already have the client upstream to Linux kernel, so it might be perceived as a dual chain, right? And some of them might require you to install additional software, right? And so that's that's different complexity to support, right? And if we can move on, the next one will be performance, right? Because one of the reasons we consider scale-out versus scale-up is because of the performance, right? We want to get more scalable performance. And then we need to consider how scalable it is, right? And so maybe we can only scale to a certain level, right? And then we need to look at what's exactly performance I need, right? Because the performance, good and bad, is all relative, right? So there are certain criteria we can evaluate. For example, throughput, right? Often when we talk about certain file system can achieve say terabyte per second. Really, that means aggregated throughput, right? But that's the overall storage can deliver. But what that means to each single client, right? And you might say some performance benchmark shows I can get saturate the 100 gigabit network completely, right? But they were using hundreds over, let's say, 128 thread. is that the real use case? Most of the times when you run application does not have that many like I/O process, right? So in fact, it's more it makes better sense to investigate say less than 16 concurrent I/O process. What performance can we get, right? Because that's will be more aligned with real life workload, right? So that's the kind of performance we need to consider because every environment is different, right? And so we just need to consider like what's the criteria we need to use to evaluate, right? For reliability,
what about
right?
What about the fault? What about the, oh, sorry, go on. I was going to ask about fault tolerance or reliability, but if you're, go ahead and finish performance.
Yeah, performance is done. Like I was going to talk about readability, right? So readability really means like how resilient, right? This solution react to the all kinds of failure. The failure can come from hardware, can come from software, right? And because we have a scale-out solution, there are more storage server and also storage like a hard drive component, network card. All the components can go bad, right? For whatever reason, one reason or another, right? So if I get this situation, does this mean downtime, or means I lose some certain capacity, or lose some performance, right? Because naturally, if I have a two server and one server goes down, the other I don't have one server and continue to serve the file system service, even though the other server take over all the storage tray, I still lose the 50% of performance because the band, I don't have one server now, right? So that's kind of thing we need to consider, like what kind of fault tolerance policy, criteria I need to be able to have in my environment, right? So that's
okay. What about availability and then cost?
Right. Availability really means like when the system is available, right? So because one important factor to consider is really downtime and operable time, right? So when you say downtime does not really mean something bad happened. That could be planned outage, right? And so because there's a new security patch coming out, or there's like a new software, or I need to do some service on the storage server or fabric, could be any reason. And it depends on how complicated the system is, the problem is, I might need to schedule downtime. Could be a day, could be a few hours, or could be a few weeks. So then, but because that's considered downtime versus the time like the file system or storage are functional, that might affect the user experience, right? And because typically data center operates, but the 99.999%, right? So that's kind of the availability criteria we need to consider, right? Because different solutions have a different availability. So it depends on how complicated it is. Yeah.
So on reliability, we should look at fault tolerance that if I lose some hardware, like either network or server or I lose a switch thing, what is going to be affected? It's not just does it affect my capacity? Does it affect my performance? And then and then for availability, we have to look at not just the unplanned downtime, but also if there's any planned downtime that's required for maintenance or upgrades and so forth. What about? Can you talk about the cost, the manageability, and the data lifecycle?
Yeah, for cost, because naturally, like scale-out solution typically have more hardware involved, like at least there will be more server, more network device, right? So then we need to consider the cost might be higher, right? And also depends on each solution has different ways to charge us for software license. Some of the software might be completely open source, you only pay for support. Some of the software charges the license for usage and by number of server, right? So that's the cost we need to factor in, right? And also because typically like scale solution will be bigger, right? And so there will be power, cooling, and like consideration involved, like do you have enough rack space? And also when we have more components to manage do I have enough training for my team to have that how much I need to pay for like a training refresh, right? So that's the cost, right? For manageability, really about like a solution complicated or simple, or you will see like different people talk about same solution might be completely different opposite opinion, right? It's all comes down like how comfortable I am, what's my experience, right? And when I have a larger storage component in my environment, and how much time I need to plan, right? Do I have enough people to support it, or what kind of support I can get from the vendor, right? And what are the tools, right? Sometimes when issue happens, and we need to understand exactly what goes wrong, otherwise we cannot prevent happening again, right? So those kind of tools are very important.
I agree. So people should look at all the manageability costs, all the total costs, not just the cost of acquiring the system, but also, as you said, software licensing, power, cooling, and then the management, training, tools, and support, and so forth. What about the data life cycle? How does the data life cycle affect your scale-out file system design?
Yeah. So this comes down to like how much time I need to keep the data, right? Some might say like, oh, I want to keep data forever. What do you need that data anytime, like to make be accessible at any time, or I can archive that data to lower performance tier, right? So even tape library, right? And so because that would affect the scale solution design, right? And if typically scale solution would offer higher performance, but also because of the higher performance also involve more components, more expensive, and you can see it's common practice is like I keep hot data, right, in the scale out like storage, and but put the data who has not been very actively used, and to either scale up storage, like scale up storage still have its space, right, because it still offer capacity, maybe much performance, but the cost might be lower, or tape library, and it's another tier, right? So that's the strategy to consider. Yeah.
Got it. Okay, let's go on. Let's continue to the next slide.
All right. So for hardware options.
Yes.
Go ahead.
Sorry. Go ahead. Talk about the hardware options for scale-out storage.
Yeah. So scale-out storage, like so there at a very high level, we have two options, right? One is the generic server storage tree and network, like those are off-shelf products, right? And you can see people use the same kind of hardware to form all kinds of different solutions, right? And so because it's generic, like it's massively produced, so most likely it has lower cost, right? And also, if the software does not really differentiate the hardware, like a vendor, you might be able to even combine, multiple vendors, hardware together, right? So that's the pro. The con is normally it's more complicated to support, right? For customized hardware, and typically you will find that storage vendor provide an all-in-one solution, right? And it's normally nicely integrated and with the software they use, right? And simple to support. You have one single point of contact, right? But the con will be typically the vendor lock-in, right? And so unless you continue buy from this vendor, and you have to buy you have to buy a completely different storage. Typically, those two storages cannot work together. And if you continue, switch between different vendors, you will find in your environment you have all this island, right? And because moving data between different storage can take time, and as gradually people don't want to do that anymore, and you will find this storage has 90% full, the other have 90% full, but you have one more storage has 90% full. You have in total you have about certain amount of capacity, but because they are all separated, then that's you cannot really use them effectively, right? So that's vendor lock-in can come with the price, right? So that's another thing.
It appears so the two major options you've described are I can buy more generic hardware or generic solution and I'll probably save money at the acquisition, but it might be more complex to support, or I can buy a customized solution. It's probably easier to support, maybe easier to implement, but it might cost me more money, and it may give me less flexibility to change vendors or to mix hardware if I get the customized solution.
Yeah, exactly. That's my point. Like, there's no perfect fit for everyone, right? And if you ask, anyone say, well, someone like who uses a certain technology, they might tell you once, love it. The other one, like who uses exactly the same technology, may think like I hate it, right? So then you sometimes because of technology evolve, right? And even the same technology, same brand, and they might have a different user experience. So it's like a circle, right? You might find that people go on round and round, like they change your opinion as the technology evolved, right? So
that's a good point. They might, yeah. So the technology evolves, they might end up changing their opinion, or switching from a customized solution to a more generic solution. Let's go on to the. Let me move to the. Oh, okay. We both. Let me go. Okay, we both clicked it there.
Yeah.
All right. So tell us about the software in scale-out storage. What are the options for software, or how important is the software?
Software is very important. Like software is actually the key differentiator of storage. Like in fact, I would say like storage is a software industry, right? Because at the end of the day, like software is what the user actually use, right? And so there are software who when talk about generic hardware, that's because some software can run like a hardware agnostic, right? So we can use the same software on all kinds of different hardware. On the surface, from user perspective, I can use I use the exact same command to mount this file system, and I can use it. I don't really care what underneath, right? So that could be the case. So when we talk about software, there are also two generic categories. One is open source software stack, right? So there are many open source, many different choice, right? And so for file, but when we build a scale-out storage, we need to look at many different components, right? So people might not realize like how many components we might need. Not just file system. File system is no doubt the most important one. However, we need to consider like how we handle the volume management or read, right? So when we have a 100 or 1,000 hard drive, and in the larger storage environment, or how do I handle make sure like have adequate protection? Or if I want to have the mixed environment, have NVMe SSD and hard drive, and how do I combine them? Like could I have a even at the bottom level, like a fast data or metadata on the store on the NVMe or SSD, and for the the object data put on the hard drive, we need to look at, right? So system management is another thing we need to consider, is like how do I manage the system, right? Like if I need to shut down entire or unmount, basically make the storage not available to a client in order to do some service, and how do I do that, right? Do I have software to do that, or have to do everything manually, right? And if I have a downtime, if one server has a hardware failure or whatever reason, and it's a software handle like automatic failover, right? That's what's for availability. Then we talk about availability, we need to consider timing. How much time takes to do the failover? Is that within time of nanosecond or millisecond, or talk about minutes, or sometimes a few minutes, right? So because different availability result would affect the workload. During the availability, would the I/O have error or just timing there, right? So that's the all different the requirement. And data migration means like really how we might move data back and forth between hot tier to like a slower tier, right? And so there are solutions out there, like if you do some research on internet, you will find them. However, because each component and for each individual purpose, you might find that they are not very easy to integrate it. On the paper, like you look at, yeah, that should work, but when you actually implement it, you'll find that there's a gap, right? And because they all belong to different open source projects, and that gap might impact your real life work, right? So that's the.
So if I choose open source software, I might have to choose not just the file system, but different other things like volume manager, what's my failover strategy solution, what's my data migration, and all the pieces might not always be tightly integrated. What about the proprietary software option?
Proprietary software is typically come from one vendor, right? And that normally is more polished, right? And they will have everything, right? And to build in, right? And they will have a volume management, automatic failover, like data management, right? So, but because it's typically they will have a licensing cost and support cost, right? And so there will be some, normally it's more expensive. But on the other side, open source software does not mean free, right? So like it might be free to use, but it will probably not be free to get support, right? So if you get a situation, the worst case for the storage administrator is I have I/O failure happen occasionally, not always, right? If I know exactly how to reproduce every single time, then that kind of issue normally can be solved rather much faster. But if that issue only happen, under certain circumstance, I don't really know why it happens, and that's very, very difficult to charge, right? So when you set that kind of situation, and your user experience will be affected, and if you have a support from the software expert, most times you can be able to get this issue resolved. But that support normally comes with cost as well, right? So we need to consider that open source does not mean free, right?
Good point. Open source does not mean free, and if I want fast support, I either need to pay a vendor for the support, or I have to have my own experts in-house, my internal experts who can provide the support.
Yeah, exactly. So that's the last point I want to talk about is like understand your support plan, right? And because you might feel like I brought support, but really I only have a support for one component, right, of the software stack, then that might not be good enough, right? So like that's what the system integrator normally show some value, right? Because they have done like validation, and like they probably have a support agreement with each individual component, and when you buy from them, and you still have a single point of contact, and but they will handle the invocation of each individual one, right?
Okay, let's go on to the next slide.
Okay, common challenges.
Yes, common challenges. Please go ahead.
Yeah. So when we talk about common challenge, really means like what kind of issue I might encounter, right, when I use the scaled solution, right? So typically, lots of times storage is often afterthought, right? So when I build out the cluster, typically I start with compute node, and because we did not know how much data I need, right? And then the storage might be under budget, right? So that's something we need to consider. Like, it's okay, right? Because like if I don't know how many users are gonna use it, how much data they're gonna generate, I cannot put lots of funding there at the beginning. That's where scale-out solution might be appealing to you, because like you can expand the system, right? Not just capacity, and also performance as you go, right? So that's something like a scale-out solution would play really well. However, even in theory, like a scale-out solution can continue scale, but not all the solution can scale indefinitely, right? Most of them would scale to a certain level. You will find that you cannot get any higher performance, or or the size of file they can support will be limited to certain terabyte, right? Or number of file can on one namespace can only be certain number, right? So that's something you need to consider, right? So ask a question to your storage vendor, like what's upper limit for scalability, right? Realistically, like how much they have deployed, so that will help you to vet the risk, right? For the cache and the consistency, right? And that's like a really two sides of a coin, right? Because cache is a very common practice to improve performance, right? So let's see, write cache, right? So if I can cache that write workload either on the client side, on the server cache side, or on the even storage controller side, right? Then I can move on, right? But what's the kind of protection I would get on the cache, right? Because if I lost that part of cache, I lose data, right? And also like for that part of cache, like how fast this can become persistent, right? I mean, like put on the final storage medium, because like if I have a situation, I have two client nodes try to access the same amount of data. One writes certain part of data, the other try to read it. If that part of data has not been on the storage server side, and the second client might be reading obsolete data, right? So that's something we need to consider. And the third one is if we have many clients access the same file, right? If we have this kind of traditional file locking, right? I'm using this file, you had to wait. That can be very inefficient in terms of performance, right? So a smarter way would be like have a display locking, right? So I only lock a certain region of the file, and so we have multiple clients can access the same file simultaneously, right? The next one will be like
you're pointing out in the caching that if you have write caching, you have to worry about the consistency, because, and then if you put the cache locally on the client, you get better performance, but it might not be protected, or it might not be fully replicated, consistent everywhere if different clients have different caches. If you have a central cache, then it's easier to keep it consistent, but well, actually, in a scale out, there's no one central cache. The cache you might have cache in multiple nodes, so you have to find a way to keep it consistent or understand that how long until it will be consistent.
Yeah, exactly. In fact, that's actually also related to.
Actually, sorry for time. Go ahead on the metadata and performance and networking. Please continue, just because of time.
Yeah, absolutely. So for the metadata and data, like they normally have a different hardware requirement, right? For metadata, like that's really index, right? So the amount of data we need from metadata is very small, but unless we know like where to find the actual data, that that metadata require very low latency. So that's where most likely the SSD and ME will be good play right on there. And so the performance and the synchronous and asynchronous replication means like there's a cost of data replication, right? Although data replication is very common among the scale-out solution in order to increase the reliability. However, we need to understand how the file or data be replicated among different servers. If it's asynchronous, and then I really have one copy, right? Because if the first copy has some issue before they replicate the second one, and I still lose data, right? But synchronous means like I need to write to multiple destinations simultaneously. Whoever finished last determine the total amount of time this operation. So normally asynchronous data replication will be slower, right? So that's cost of performance. For networking requirement, and so because when we talk about scale-out solution, we really means like multiple servers can function together, form a single namespace, and normally we will have a very fast speed data network, right? And but even for different network topology that come with different costs, right? And typically we want to have a storage on the root side of that topology, so that's where like we'll have more even performance to the client, right? And balance means when we design the system, we need to consider like what kind of performance we need on like a front side and also on the back, right? So because if we make a certain component very high performing, but that's not the the bottleneck, we might not get better performance, right? The also havability timing, we'll talk about that. Like if it takes too long to do havability, it might impact your workload, right? And in the built-in tools for provision management triage means like if I need to do some service on the storage and what option I have, and this especially triage, right? So if you see certain like a storage solution generate lots of logs, right? Some might see like error, some might see a search, some might see like a warning. Don't assume like this is bad. This is actually really good. That means like this solution has been out there, has a lot of exposed to customer use case, and they know this. Those kind of information can help you when actually something go bad, right? And the worst case is it's all silent, but you did not really know there was issue until a few months later, and then there's no way to triage you to find out what's going wrong. And if we cannot know why it happened in the first place, we cannot really prevent it happening again, right? So that's the kind of consideration we need to take into account.
You're saying that you need management tools that help you understand what happened and why it happened if you have any problems,
yeah,
so that you can fix the problems or prevent it from happening again.
Yeah, exactly.
Okay, understood. Okay, good. Please keep going. What about benchmarking? How do you benchmark scale-out storage? What's the right way to do it? What are the tools that are available to do this benchmarking?
Right. So for benchmarking, and this is important when we evaluate scale-out solution, because typically performance is one important factor, right? And so we have a couple of tools, generally available, right? You can use it like the VDBench, right? And that's really, you can both do the block level benchmark, you can do a file system benchmark, right? And different cache hit rate mix different read or write, right? And the same for FIO, right? And they can also do this kind of like different workload, right? For IOR, IOZone, that's more popular among like a large environment, because we can schedule them concurrent read or write from hundreds of thousands of clients, right? And metadata, the MD test is one of the popular tests to evaluate metadata. When we say metadata, the criteria is not the throughput. The criteria is the number of operations, right? So how fast can I remove the file or create file, right? And in general, we'll need lots of clients in order to saturate metadata, right? But having said that, right, those synthetic benchmark tools, right, does not replace the real-life application, right? So as I mentioned the example earlier, right? So you might see some of white paper show like they can get a certain level of performance, but when you look at closely, they require to use the 128 like a process per client, but which client would use 128 IO thread, right? And most times, real-life application does not have that many IO process, right? So that's the thing we need to consider, right? Like synthetic benchmark can really evaluate what the system is capable, but it does not really means like that's what your user would experience, right? And another thing is be creative on what could go wrong, right? The kind of rainy scenario, right? Because if most of the time we got the performance in the ideal situation, but let's say if I have hard drive failed, or if I have a storage controller failed, and within a situation, how much performance I will lose, right? And then we need to consider this would affect us when we do the capacity planning, right? So yeah, that's the kind of rainy scenario. Yeah.
Okay, so we'll talk more about, I think on your next slide you talk more about the rainy day scenarios, but let me go back for just a second. We do have one question I want to answer. The question is, what is the observed bandwidth limit for a single node, just to understand what are node capabilities and when we need to think about scale out? So I'll answer from the network side, which is not always what the node can do, but from a network limit, your typical limit on a node is either about 100 gigabits per second or 200 gigabits per second, depending how you set up the networking, whether you use one network card or two, and how many PCIe lanes. But if your network card plugs into a PCIe Gen 3 slot with 16 lanes, you're limited to about 100 or maybe 112 gigabits per second, which works out to about 16 to 18 gigabytes per second. If you are willing to use two slots at the same time, then you may be able to get up to about two slots, PCIe Gen 3 16 lanes, get up to about 200 gigabits a second or a little more. Ziki, what about from outside the networking? What would you say are the typical bandwidth limits for a single node?
Right. So that's what you talk about is the network hardware, right, capability. But when we look at
I was talking only about the network hardware, which is not the only limit.
Right. That's one of building block we need to consider, right? And but like when we have evaluate the real life solution, which include the storage server and the storage software and the backend, right? And so that's could be very different, right? And and also we need to consider like the workload, right? Because when we say the limitation does not really mean like a throughput or number of IOPS or certain latency. It really means like concurrency, right? So like if I have the 100 clients, each of them write homogeneous like the large function IO, right? That kind of performance limitation I got exposed will be totally different than I have the same 100 clients, but each of them have several concurrent processes write 4K IO, right? That's a 4K file, right? That generates lots of super file. And we could have a situation, the client, each of them open one file, they write a couple kilobytes, they close. Then they run sync, right? And then use fsync, right? Then they write another few kilobytes, then fsync. That's another limitation, right? So it's all different, right? So we can use a synthetic benchmark to simulate a certain scenario, and but the indication, right, and whether you are saturated by the single server or not is to see you run concurrent job on multiple clients, and to see what kind of performance improvement you might get, right? If even because some workload they might function differently, right? So I even have let's say 10 clients write to the same storage server, but each time they write, we have different clients write to a different file at different time. I may not be bottlenecked by that, right? So this really look at what kind of performance evaluation criteria you are looking at, right? In terms of your environment, yeah.
Okay, please go on with more into the rainy day scenarios for testing.
Okay, so rainy day scenario would be like, for example, hardware failure, right? And so drive failure, controller failure, server failure, network failure, right? And so how much capacity performance I might lose, right? And then I need to consider. And when I need to do a software upgrade, right? And can I do that each server each time, or I need to do that all of them together? Means like I need to shut down the storage completely, right? And also disaster recovery, right? And so some of enterprise environment they really need to have the time 24/7, right? And they cannot have any time slowed down. And so they might choose to replicate entire storage to another site, which is maybe sometimes a few hundred miles away from each other. And so we need to practice this kind of like disaster recovery, right? And so when on a regular basis, right? And then because normally remote site would the long distance network would have a higher latency and lower bandwidth, and so what's that impact to your operation, right? That's something we need to consider. Silent data corruption, right? That's something nobody wants to see, but it does happen, right? And so we need to understand what kind of protection this storage would have, to cope with sudden data corruption, right? And then also we need to consider like what kind of workload I might have, right? And because that's it's hard to predict future, but sometimes we know like when we might need to think bigger, right? Not just what we have today, right? Eventually, right, and there will be a trade-off, right? Because we can continue add more requirement than the requirement for the feature, right? Requirements for capacity, requirements for performance, for safety. In the end, it become more expensive, right? So that's the time we may need to consider, okay, is that the only solution I need to look at, or I need to actually separate them, right? Because different storage requirement might have a different level of reliability, right? Maybe if I just need to have a very high performance tier, like all my unrecoverable data is already protected on another storage solution. For the performance tier, just for the calculation purpose, maybe I can like trade off. I can sacrifice some of like the reliability, but I guess more cost effective on performance, right? So that's the level when you reach to your bursting point, right? But like really just consider like trade off. There's no perfect solution, and how we balance between those requirements, right? And because that comes down to in the end, we all want to make our customer happy, and but different customers have a different expectation, right? And then that will be trade-off. Yeah, that's my point.
Okay, very good. Let's go on to talk a little bit about, excuse me, what are some of the popular scale-out file systems, or what are some of the choices out there if you're looking for a scale-out file system?
Right. So I intentionally do not want to show the preference to any like technology, so I do not have their name there. But what I can tell you is a very scattered market, right? There's no if I say one technology is very popular, and there will be 100 people saying like 100 others solution are better, right? And because really it comes down to like a perception, right? So how you look at in this market, but it's very scattered. Like there's no single dominating technology, and so if you search for like parallel file system, cluster storage, right, and you'll find them, right? And as I mentioned, like in general, there are two options. One is based on open source software. The other based on proprietary software. Like for both the just the hardware software only. Like software only normally means so I can run on generic hardware, and all there can be like hardware plus software integrated solutions, right? And but in the end of the day, like each of them has a pro and con, and so it's hard to tell like which one is the best. It's really the best and for like a certain scenario, right? And if we go back to what we talk about, like come down to the requirement and also the let's say like the kind of supportability, and also what kind of training you might have on your side, right? And do you have adequate manpower to support it? And another thing yeah, go ahead.
Cloud, go ahead. I think you're about to talk about the cloud service providers. What about them?
Yeah, so like you will see like lots of cloud service providers have their own scale storage, right? And so that's only proprietary to their environment. It's not available outside. And also on top of their scale-out storage architecture, you might be able to build another layers of a parallel file system on top of it, right? And but fundamentally they have a similar like architecture, right? Really it's aggregated multiple node storage component together, right? And the same kind of evaluation criteria I talk about would apply in the cloud environment as well. Yeah. Okay. All right. You want to talk about summary slide? Yeah. Oh.
Yeah, let me go ahead and talk about the summary, and then there's a question about the cloud scale-out file system, and I'll have you answer that question. But first, on the summary, let me summarize what we talked about. So clearly, scale-out file systems run across multiple hardware systems. That gives you extra performance and extra capacity, but can introduce more complexity. So they offer some advantages in performance and scale. There are many versions of scale-out file systems available. They're both open source and proprietary systems. And there are many options and trade-offs to consider. One of the options, some of the options include whether you want to buy the hardware and software separately or buy an integrated system, whether you go open source or proprietary. And then it's also whether you want to have the dedicated storage and client nodes versus the hybrid nodes. And then also issues of how do you deal with the metadata, how do you deal with networking, data movement, data migration and data tiering, disaster recovery, high availability. Well, Ziki covered a lot of these, but there are many different options and many trade-offs to look at. So when it comes to testing, you want to test, you figure out, what workloads and what requirements your applications need, and then test to those. But you also want to make sure you test real-world workloads and real-world scenarios, not just standard synthetic benchmarks. And that includes testing for rainy day scenarios, such as failover, upgrades, lost hardware, changing workloads, growing data capacity. These are just some of the rainy day scenarios that Ziki covered. So I think that's a good summary of it. After the webcast, we do ask that you rate the webcast and provide feedback. We've got free feedback from 3 people so far, so thank you for that, but we'd encourage all listeners to go ahead and provide feedback and give us a webcast rating. As mentioned before, the webcast will be available for replay on BrightTalk, and the slides will be posted as a PDF to the SNIA Networking Storage Forum, NSF website, at the link shown on the slide. A Q&A covering all the questions that we got to and the ones we didn't get to will be posted as well, usually in 1 to 2 weeks. And if you want more information about SNIA NSF, you can follow us on Twitter at SNIA NSF, or you can look at our blog, SNIA-NSFblog.org. So Ziki, let me go ahead and try to grab a couple of questions. We're just about out of time, but one question is, which SOFS, or scale-out file system, presents on Windows and Linux platforms? And the other part of the question is EFS on Amazon Web Services a scale-out file system? So can you answer the second part first? I'm not familiar with EFS. If you are, that'd be great. Is EFS on Amazon, is that a scale-out file system?
Yeah, there's a definition on the AWS website, and from the description, I don't personally have experience on that one, but from the description, it sounds like it's a scale-out architecture, right? And for the first question is, I guess the question is about if I'm in Windows, can I still use the scale-out storage? Answer is
yes. I think the question is there one? Well, the question either means is there one scale-out file system that can be used for both Windows and Linux, or they're asking which scale-out file systems work with Windows and which ones work with Linux.
Right. So that's actually another tier of complication, right? So typically you will find typically there are native client on Linux for most of scale-out software, scale storage software, right? But there are software who also have native client on Windows. But even though they do not have, even some of them do not have native client on the Windows, we can still use, say for example, Samba gateway, right? And so that way, we can re-export the namespace through the safe, right? On Samba service on Linux, right? So we can create this cluster of the Samba gateway, right, to offer this scale-out architecture, and so to the Windows user, right?
Good point. So you're saying some scale-out file systems might have a Windows client, some have a Linux client, but if your scale-out file system does not have a client, say, specific to Windows, then you could use a Samba gateway or maybe use, I think Windows, to access it, where the Windows servers can use SMB to go through the Samba gateway to get to the scale-out file system. Or I think most Windows machines also support NFS. They might not prefer it, but I believe most Windows machines can talk NFS. And so some scale-out file systems can be accessed through NFS if you don't want to install the client or don't have a client.
Right.
Okay. Let me just see here. So, oh, well, okay, that is all our slides. I think it was one comment that Spectrum Scale does this already. I think they're saying that Spectrum Scale can support both Windows and Linux. I think that's but we'll address that more in the FAQ. One more question before we wrap up, Ziki. The question is, how do you address the problem of a specific disk going down or a specific disk failure? Where does scale-out architecture provide redundancy? Can you answer that question?
Right. For the individual drive failure, typically that will be handled by the volume tiers, right? And so that can be, addressed either through replication, right? And for example, I use each individual drive, and I form a file system on top of each drive, but I use another tiers to glue them together, right? And then have a multiple copy. Another way is more traditional way is I create a read group, right, on top of the drive, right? So that's way, let's see if I have a read 6, right, and then I can tolerate 2 disk failure, right? So then that's those kind of failure. Some of the read group has a really good design and does not have the performance penalty. Some of might be, right, and but from user experience perspective, the impact will be minimal typically. Yeah.
Good. That's a good point. So a scale file system, they could spread the data across multiple nodes, or they could do RAID, RAID on one node, or they could do a combination of both.
Mm-hmm. Yeah.
Okay. All right. Excellent. So there are a couple more questions that we didn't get to, but we're slightly over time. So I'm going to go ahead and end the webcast. Ziki, I'd like to give you a big thank you for presenting on this webcast. I'd also like to thank everyone who attended, and a reminder that the slides will be posted. The webcast will be available as a replay. The slides will be posted on the SNIA website, SNIA NSF, in the NSF part of the SNIA website. And again, we will take all the questions, including the ones we didn't get to, and go ahead and post them as an FAQ in the next week or two. Again, if you have a chance, thank you to everyone for attending. If you have a chance, please do give us feedback and a rating. And we look forward to seeing you on the next SNIA webcast. We will have many more coming up later this year.
Okay, thank you everyone for attending. Yeah.
All right, I'm going to go ahead and end the webcast. Again, thank you, Ziki, and thank you to all our attendees. Look forward to seeing you soon on another SNIA NSF webcast.
Okay, bye.
Bye-bye.